Welcome to aminacademy.com. In mathematical economics, regarding optimization of multivariable functions, let us do some solving problem. Look at this example. For the following cubic equation, that is f equals 3x cubed minus 9xy plus 3y cubed. Find the critical points. Determine if at these points the function is at a relative maximum or relative minimum or inflection point or saddle point. So I have to check these conditions. Now the function given is f equal 3x cubed minus 9xy plus 3y cubed. Then we have to get partial derivative with respect to x and y separately. First, dou f by dou x, that is fx equal 3 into 3 is 9x squared. 9xy partial derivative with respect to x is minus 9y, and 9y cube differentiation is 0 because with respect to x. So separately equating 0, which gives the condition y equal x square, means 9 and 9 cut, and y equal to x square, the first condition. Next, with respect to, that is f of y, with respect to, differentiate with respect to y partially, so it becomes 0. This becomes 9 minus 9x plus 9y square, which gives x equal to y square. The second condition, x equal to y square. So we have two conditions. Then this x equal to y squared substitute here, this let it be 1. From 2 we can get x equal to y squared, substitute in 1. What happened? Y equal, that is y equal to x square, we have to substitute x equal to y square. Therefore then we can get it x equal to y square, that y equal to x y equal to x square. Therefore x equal y square is y is x squared, therefore x squared dot square, which gives x equal x power 4. Therefore x power 4 minus x equal to 0, then get x common, x cube minus 1 equal to 0, which gives x equal to 0 and x equal to cubic, x cube equal to 1. This two values, x equal to 0, x cube equal to 1. Then regarding y, first y equal x square, which gives y equal to 0 square 0, and another y equal, then y equal 0 we got, and x equal x equal to 0 and x cube equal to 1. Then put here x value is 0, then you can get y is 0 square is 0, as well y is 1. We are having the critical points now. That means you are substituting y equal to x square, we will get y equal to 0 as well as y equal to 1. Therefore the critical points are X is 0 means y is 0, x is 1, y is 1. These are critical points. Then testing the second order conditions. Second derivative condition, second order condition. Here fxx means the derivative of fx with respect to x, second dou square x by dou square y by dou x square, which is already we have this fx is 9x square minus 9y. Derivative is 18x. fx is 18x and fyy is, look at here, if yy means this 0, this is 9. If yy is then fy is this 18y. 18y. These are having two values. Then the at critical point substituting f of xx at 0, 0 is 0. That is 18 into 0 is 0. Here fyy at 0, 0 is 18 into 0 equal to 0. Then f of xx at point critical point 1, 1 equal 18 into 1 equal to 18. This side f of yy at 1, 1 equal 18 into 1 equal to 18. Now look at here, this fxx at 1, 1 gives greater to 0 because 18 is positive values. F of yy at 1, 1 is also 0, greater than 0, that positive values. Now that another condition, the cross differentiation, which is fxy. That means differential of fx with respect to y. With respect to y, differential of x with respect to y is this constant, that is we have minus 9. Similarly, f y is it also minus 9. Therefore, from this we can say fxy, fyy equal, which is equal minus 9. That's second condition. Therefore, in general, we can write f of xx at point AB dot f of yy at AB should be greater than f of xy at the point AB, critical point AB, the square. This condition will check f of xx zero into 0 is lesser than f of x AB square is minus 9 square. Of course, 9 minus 9 squared is 81, positive 81, so it is, which is greater than 0. Next one, 18. Other values, 18 into 18, which is equal, this minus 9 squared must be 81, but 18 into 18 is more than 81. So these are the conditions. This is at 0, 0, here at 1 and 1. Now with f of fxx and with fxx and fyy greater than 0 and if fxx fyy is greater than f of xx the square at 1 1, at the point 1 1 it satisfies. The function is at the function is at relative minimum, is at relative minimum at point 1 1. Minimum at 1 1 with another condition, with fxx and fyy of the same sign at 0 0. Both are having same sign at the critical point 0 0, and fxx is lesser than f of xy the square. Therefore the function is at an inflection point. Inflection point at 0 0. These are the conditions we satisfy. So far we discussed some example problem regarding finding critical point or inflection point or relative maximum or relative minimum we checked. We have done. Please subscribe our YouTube channel.